Thanks so much for joining part 2 of our detection series on Windows Management Instrumentation, or WMI, which you'll hear us say a lot. My name is Matt Graber. I'm the Director of Threat Research at Canary, and I'll be hosting today's webinar. I'm filling in for Greg Bailey, who unfortunately couldn't make it today. Yeah, those are big shoes to fill. I'll try to do my best though. So let's get this out of the way. First of all, is this going to be recorded? Yes. And the link to the slides and the video will be available to everyone who has registered. All right, so again, I'm Matt Graber, and today with us we've got Joe Savini. He's one of our principal solutions specialists, and Julie Brown, one of our awesome detection engineers. They're both going to be doing a deep dive into what the telemetry actually looks like if you're to work in a commercial product. In this case, they'll be diving into Defender for Endpoint and how they can go about investigating WMI tradecraft using that platform. All right, so today's agenda, we're going to be diving into the detection test challenges that we posted yesterday. Next, we'll examine and analyze the telemetry that the test generated, and Julie and Joe are going to be handling that for us. And then we'll discuss best practices for building effective detection analytics around WMI tradecraft. All right, so again, yesterday we posted a WMI challenge where the first part had you run through the steps to set up logging WMI tradecraft, specifically WMI persistence using Sysmon. And then there were some questions that followed after you ran the live demo to actually install WMI persistence on a test system. So I'm going to run through the questions real quick in the slides, and then I'm going to jump over to my VM and walk you through my thought process for how I would go about answering these questions. So the first one, under what conditions will notepad.exe launch? So in this case, the WMI persistence, what it actually executes when it triggers, in this case, is benign and just launches notepad.exe. So we'll discuss those conditions under which that launches. Next, assuming the conditions are met to actually launch notepad.exe, what will it launch as a child process of? Next, assuming that WMI persistence was successful and that we got our Sysmon logging configured properly, what Sysmon related events will be created that would indicate that WMI persistence was actually performed? And then finally, as a way to supplement Sysmon logging, in Windows 10 and I believe Server 2016, don't quote me on the server version, but in the WMI activity operational event log, which event will be surfaced that would also indicate that persistence was performed? So let me jump over to my VM now, and we can start digging into this here. All right. So here is the test code that we had everyone execute for everyone who participated. And as was discussed yesterday, in leading up to this, it was covered that there are 3 components that are necessary for performing WMI persistence. There's an event filter, which comes in the form of a WQL or WMI query language query. And this specifies the conditions under which the payload or just executable code would actually run. So in this case, the conditions under which notepad.exe would run would be the following. So kind of getting into the weeds here, let's start at kind of a lower level and then work our way up to more of a conceptual level of what's actually going on here. So this is a WQL event query that states anytime a WMI object, in this case, is modified within a 60-second polling interval, and because of the type of query that we're dealing with here, this is referred to as an intrinsic query, you have to specify a polling interval. So anytime a WMI object is modified, where the target instance, the instance of the WMI object, happens to be a Win32 performatted data perf OS system class. So whenever that class or an instance of that class is modified and its system uptime is between 240 and 325 seconds. So this system uptime property is a property of this class, which if you were to Google that, you'd find there's MSDN documentation for this. And so let's come up to the higher level and conceptually walk through this a little bit. So the way you can interpret this is that it will run at least once, sometime shortly after system startup, so between 240 and 325 seconds. I say we'll run at least once because of the specified polling interval. It could actually trigger twice within that interval. Usually it would just trigger once. And so anyway, I guess one question would be like, how could an attacker actually have come up with that? And the short answer is WMI eventing often requires creativity. And in this case, there's really no super straightforward WMI class that represents system startup time. And so just after digging around and seeing all the WMI classes that existed on the system, this was a good candidate because of that system uptime property. And so I discovered this way back when, I want to say the 2013 timeframe. And I incorporated this logic into a persistence module in PowerShell that I released a while back. So again, that is the specific condition under which notepad.exe would launch, where notepad.exe is specified as part of our event consumer, the consumer being the thing that executes in response to the event filter triggering. And then to actually install and perform the WMI persistence, you have to bind the filter and the consumer together. And we do that by instantiating an instance of this filter to consumer binding class. Now, if you were to run this in your lab environment, reboot the system, and also have process monitoring running, you would have found that notepad.exe launched as system as a child process of the WMI PRV SE.exe process, which is one of the executables associated with the WMI service. So you'll find that very consistently, whether we're talking about WMI persistence using these techniques here, or in the case of like WMI lateral movement, any child process that's created as a result of WMI will launch as a child process of WMI PRV SE.exe. Now let's talk about logging. So here we are in the Sysmon log. And the quick and dirty answer to the challenge question is you'll be looking for event IDs 19, 20, and 21. Event ID 19 will cover the creation of the event filter. And so you get the context there, the conditions under which this will trigger. Event ID 20 will capture the context around the event consumer. Now, in this case, our event consumer was a command line event consumer where notepad.exe was being run. But as Christopher Glyer mentioned yesterday, another popular event consumer is ActiveScript event consumer, which would allow an attacker to execute Windows script host code like JScript or VBScript. And then finally, event ID 21 represents the filter to consumer binding. So the context that you get here is the name of the consumer and the name of the filter. And then as a defender, if you're investigating this, then you can correlate these names to the corresponding consumer event, event ID 20, and the corresponding filter event, event ID 19. All right, so the last and final question from the quiz from yesterday is what log would surface in the WMI-activity event log. So this comes in the form of event ID 5861. And here, we just get a single event where all of the context is merged together. So this may be quite as readable as the Sysmon logs. But one thing that I like about this event log in particular is that it's extremely robust. I gave a Black Hat talk with a former colleague of mine, Lee Christensen, where we covered various WMI persistence detection evasion scenarios and found some limitations in Sysmon's ability to log WMI persistence. But this event ID 5861 event was resilient against all of our evasion attempts. I can post a link to that talk a little bit later on. But just so you know, the benefit that you get from this event is that it's extremely resilient, and it's also built in. So like this will be logged automatically. So there's no configuration like there was with Sysmon that's required. All right, let me go back to my slides. Okay. All right, so let's transition over to our demo. And for this, what we'll be showing is the resulting detection artifacts from the test challenge. Instead of looking at Event Viewer manually like I did, Joe and Julie are going to be running through how to do this in Defender for Endpoint, how to triage WMI related events, and then also how to use Microsoft's Kuso query language to try to perform some threat hunting used for WMI baselining. So you want to take it from here, Joe?
So when you first jump into Defender for Endpoint, you're going to be viewing the security operations dashboard. And in order to find the alerts that we're looking for, we're going to jump into the alert queue. And sometimes these alerts will be correlated into an incident, but not always. And the easy way to tell when you're viewing WMI related alerts in here is that it will literally give you a title that is related to WMI. And if you kind of scroll over here, you can see which device those spawned on. And you can get a preview of it by clicking it. But honestly, the best way is to drill into it by clicking the name of it. So depending on how you have your Defender configured, sometimes you'll be viewing it this way, which is honestly the most common way. This is the original view, the original alert view, but this doesn't really break things down as granularly as we would like, especially for things that are fileless, where we're not going to get all that data presented here that we want to see. So I always recommend toggling this box in the upper right-hand corner, this try the new alert page. And at first, it might look a little sparse, but then as you dive into the alert story, they call it, you can actually get some information about that consumer that Matt had mentioned and was showing manually. And down here, it's going to parse it out, consumer, namespace, et cetera. But down by the possible cause, you'll actually get even more information that is related to it. So you're going to essentially be getting a lot of the information that you were getting right from the event viewer, but kind of presented to you directly inside of Defender for Endpoint. So this can be great because it's giving you, it's bubbling up all those suspicious events to the top. So rather than having to look through, everything inside of Event Viewer and try to determine the boundaries around where the malicious activity took place, Microsoft is doing their best to kind of draw those boundaries for you and guide your investigation. And another aspect that they're doing here in terms of guiding their investigation is presenting it in a timeline view. So on the right-hand side, you can scroll through the alert details. Something that might be useful immediately is that you can click on the MITRE information, and that will take you to the MITRE attack framework page that's related to this particular behavior. But even more interesting is this See in Timeline view. And if you click See in Timeline, it's going to pivot specifically to that machine timeline inside of Defender for Endpoint, which gives you a lot more information about what was happening kind of before, during, and after the malicious events took place. So we can see here, this is the process name for WMI that's spawning these events, as well as highlighted, like it says up here, the highlighted alert, which was the alert that brought us to this pivot, which is the WMI event filter bound to suspicious event consumer. Because in this case, we have a few indicators of compromise, including notepad.exe, you might want to do some kind of manual, some light hunting, if you will, just by searching through this timeline for things like notepad.exe. And keep in mind, when you do that, you're only searching this highlighted area up here in blue. But when you do that, you're going to get this interesting information, and we can see that just like we predicted it would, that we have this process and it is creating notepad.exe. So it's breaking it down for us and showing us exactly the order of operation with the entities that are involved in this, as well as a really cool entities graph. And the neat thing here is that with just a single click of anything in here, you can pivot to more information about that inside of Defender for Endpoint. But none of that's really that interesting right now. It's just, maybe for other types of use cases and investigations. But for this particular investigation, I think the most important thing for us to do would be that now that we've looked for some of those indicators and we see things, we know that Defender has helped us bubble those to the top, we can actually begin to do some advanced hunting to see if we can get some more information that's not exactly presented to us on the surface level and not parsed for us as maybe as cleanly as we would like it to be. So with one click up here, what Defender can do is it can actually begin to generate Custo queries for us and pivot that into the advanced hunting framework that's built into Defender for Endpoint. So we'll go ahead and click that. And that will generate a query to show us these events that happened within that specific time frame on this machine. But the cool thing about this is that it gets a lot deeper than this. And I wanted to pass it over to Julie to talk a little bit more about that and how you can manipulate these queries to really get the results that you're looking for.
Joe led us to this advanced hunting view here, and I'm going to go over some basic threat hunting concepts for baselining WMI in your environment. So in this case, we are using the Microsoft Defender Security Center platform to do that investigation, but these concepts are going to apply regardless of what EDR solution you're using in your environment. So the advanced hunting query that's automatically generated by Microsoft in this case is specifically looking for everything that happened on an endpoint within a specific time frame. But we want to ask some questions about the environment at large and not just a specific endpoint at a specific time. So we're going to kill all of this out and start from scratch. And the question that we're asking for baselining an environment is, what are all of the child procs of WMI related binaries in my environment? And do all of those child procs make sense? Are those all things that I want to be running in my environment? So we're going to start with the broadest information we can, which is, what type of device events are we looking at? And if we look through the schema on the left side here, Microsoft provides us with a catalog of what you can search for in advanced hunting. And in this case, we're looking at device process events because we are asking a question about process lineage. So we'll start the query by simply querying for device process events. And if we take, if we start there and we just run this query, it will give us, as you expect, every single thing that Microsoft is storing, but that's not going to be useful for us. In this case, we want to search for device process events where the parent proc specifically is WMI prvse.exe. So in Custo query language, which is Microsoft's query language, the parent proc is referred to by the initiating process file name. So we'll use that here. And we are looking to find events where the initiating process file name is WMI prvse.exe. And so we'll run that query and see that we don't get anything back at all. And this is weird. And this is one of the, I guess, quirks of the Microsoft query language, which is that this query is case sensitive, the way that I've written it here. And Microsoft records this process name with a mixed case. So we're, instead of doing the binary equals operator, we're going to do equal tilde, which will make this a case insensitive match. And now you see we start to see results. And I'm trying to get a list of all of the possible child procs. And you can see here that that value is in the file name column. So I'm going to ask for a summary of that column. And we want to know how many times each of those processes is occurring in our environment. So we're going to do a variable called instance count. And we can make this variable whatever we want to call it. And we're going to call that count the file names that we see in our results here. And now we have a very simple, easily read list that shows us everything that WMI prvsc.exe is spawning in our environment. And from this view, you can tell that this is very obviously a test environment, because the only things that we have spawning from WMI are stuff that wouldn't really make sense in a normal environment. But I would encourage you to run this query or whatever the analog would be for your EDR solution in your environment and just do a gut check of everything in this list. And you can order them in different ways. Microsoft specifically will let you view it as a graph or as a chart if you do have a very, very long list here. But this is a useful exercise just to ask, you know, am I aware of what's happening in my environment? Do I approve each of those use cases? And this also gives you a baseline to refer back to if something ever does hit the fan and you do see persistence via WMI in your environment. You can refer back to this list that you've put together and say, hey, you know, this was not being spawned by WMI 2 months ago, and now it is. What changed? And that can help lead you to some additional investigation. So this is a very high level view of, you know, how to hunt for child procs, how to find baselining lists in the Microsoft Security Center product. And with that, I'm going to pass it back to Matt.
All right. So what are our practical takeaways here? First, sort of summarizing day one and day two of these seminars is that WMI is a super powerful tool for attackers. There's very little that you can't do across the kill chain or the MITRE ATT&CK framework in WMI, whether it's discovery, lateral movement, persistence, various other tactics and techniques. WMI is super powerful for enabling you to, as an attacker, to do all those things. Fortunately, as a defender, there's definitely some hope. It certainly depends on what WMI specific technique is in play, where we may or may not have a particular advantage. So it's really key to understand if we're talking about persistence, not only what happened in the persistence, for example, like what is the event filter and what does the event consumer consist of, but also how that was created in the first place. And so something like Defender for Endpoint can give us some options to not only investigate what happened, but how it happened. For example, digging into the data, you would likely be able to see, for example, via some of the PowerShell related telemetry, many of the PowerShell commandlet names that were used in the timeline view or via KQL queries as well that were used to perform the persistence. And so there's definitely additional context that you can get beyond just the raw event of WMI persistence occurring. Now, more broadly, something like Defender for Endpoint and using the KQL queries that Julie was showing us give you a tool set to be able to baseline your environment. And as Christopher Glyer from Microsoft was saying yesterday, in the case of WMI persistence, Fortunately for defenders, it's a relatively low volume event. And when it does occur legitimately across your fleet, you'll likely have the telemetry available to you to quickly triage that and determine whether or not that was expected. But again, like it totally depends on which technique related to WMI that we're talking about. So with that, I wanted to transition into Q&A. And unfortunately, yesterday we didn't really save a lot of time for Q&A, so I wanted to address some questions that came up from yesterday that will obviously be relevant to today's discussion as well. So one question that came in was, does WMI require administrative access? Short answer is it depends. If we're talking about doing WMI tradecraft locally, you usually don't require administrative access. There are definitely exceptions to that. And one notable exception is in performing WMI persistence. So WMI is securable via like mandatory access controls. So if you're familiar with the concept of security descriptors in Windows, so those apply to files, registry keys, processes, what have you, but they also apply to WMI namespaces. So a namespace, think of it like a container for one or more WMI classes. And there's a handful of WMI namespaces, and that is the securable units in Windows for WMI. And so each namespace will have its own security descriptor for it, many of which will be openly available to any authenticated user locally on the system, again, with just a few notable exceptions. Now, where permissions really start to come into play is when we're talking about doing remote WMI operations, in which case, by default, you would have to be in the administrators group. And I believe, if my memory serves me correct, one of the remoting options for WMI, so the classic one is DCOM, but one of the more modern ones is WSMan or WinRM. So if you're using PowerShell remoting in your environment, then you also kind of get WMI remoting for free. And in order to do those operations remotely, you'd either have to be in the administrators group or a member of the remote management users group, which is empty by default. Next question. Sysmon has 3 types of events dedicated to WMI, but post installing the Sysmon with WMI enabled configuration, it only records the 3rd event. So if you're only seeing the 3rd event, presumably this person was maybe just talking about event ID 21, or maybe one of the other ones. I'm not quite sure. If you're not seeing event ID 19, 20, and 21 with Sysmon, then I would assume that something got screwed up along the way when you were performing the persistence. So it could have been that the filter failed to install properly, the consumer failed to install. And if either one of those fails to install, then the filter to consumer binding will also fail to instantiate. So that could be the reason there, if you're not seeing all 3 of those events. Question, was WMI involved in any ransomware attacks in 2020? I don't know off the top of my head. Joe, Julie, do you happen to have any insight there? No. Yeah, sorry. Okay, next one. Was WMI involved? No, that's the same question. Will all WMI activity be shown via Sysmon logging? No. So that Sysmon logging that I covered earlier, event ID 19, 20, and 21, only pertains to WMI permanent event subscriptions or WMI persistence. Considering the wide range of WMI tradecraft, Sysmon, fortunately, is not built to detect every conceivable method of WMI tradecraft. Now, it could be used to potentially identify WMI tradecraft, but it's not going to call out specifically. And so one example that comes to mind is if you are doing process logging, as I mentioned before, and as Julie showed, you can look for any child processes from WMI-PRV-SE.exe. So if you're seeing, say, like a suspicious child PowerShell.exe or WScript or CScript process from that parent WMI-PRV-SE executable, then that could indicate that that came via WMI lateral movement, but it could also indicate that it came via WMI persistence. The process logging alone is not going to tell you that. In the case of the WMI persistence, again, obviously you're going to need those event IDs 19, 20, and 21 to positively confirm that. Yeah, there's probably not too many additional opportunities using just Sysmon to detect other forms of WMI tradecraft. But briefly, I'll show some rather creative examples that you could consider in your environment for detecting any form of WMI tradecraft. All right, next question. Do these executions always spawn under the system context, or can you bind to a user account? To the best of my knowledge, those child processes, in the case of WMI persistence specifically, will always spawn as system. And the reason that's the case is because the way that WMI works under the hood is there are these things called WMI providers. So a WMI provider is a DLL. It's like a COM-based DLL that actually implements all the functionality within a given namespace. So the namespace that we used to do our persistence was the root/subscription namespace. So there's a DLL under the hood that implements the ability to do all that persistence. And within that, when you go about registering a WMI provider, you have to specify the context under which it executes. And the provider that performs the WMI persistence is registered to run under the system context. So that's why in the case of WMI persistence, you'll always see those child processes spawn in the system context. All right, next, is WMI limited to what you can get if you are not an administrator? I think that would probably be related to one of the previous questions where you could be any authenticated user to do most WMI actions. So, all right, so I'm just a standard authenticated user here on this VM. Oh, let's get WMI object. And if I just wanted to do, if I want to enumerate all running processes, I'm telling WMI to get me all instances of win32_process objects. This is just one of thousands of examples of things that I could do in WMI that would not require administrative access. Now, other security controls are going to be in place. For example, as a standard authenticated user, I'm not going to be able to see the running processes of other users or processes that are running in the system context unless I've got an elevated PowerShell prompt here. All right. Next question. Would there be any options to log without using Sysmon? Yes. So as I mentioned in the WMI-activity log, there's event ID 5861 in Windows 10. And that is a fantastic source of logging for just WMI persistence. And I actually wanted to call out earlier when Joe was running through his demo, he was highlighting the WMI persistence alert that Defender for Endpoint surfaced. And the context that it showed was all of the WMI registration activity that occurred. So the event filter and event consumer. If you were paying attention when I went over the event ID 5861, you would have seen that the content of event ID 5861 was identical to the context that Joe was seeing in his Defender for Endpoint alert. And so what that can indicate to us is that Defender for Endpoint is pulling in the same log source. Now, under the hood, it's not actually pulling it from the event log, it's pulling it from ETW. But both the event log and Defender for Endpoint are both consumers of ETW, or event tracing for Windows events.
Matt, if
Yep.
I can add there too, one of the things that's interesting, if people are want to use Defender specifically for logging WMI related information, is that there's an attack surface reduction rule that's been created that blocks process creations originating from PS exec and WMI commands. And so if they're a Microsoft shop and they want to implement that attack surface reduction rule, they can leverage Intune or what have you, PowerShell, to implement that. And there's several different kind of modes that those attack surface reduction rules can be implemented in. And one of those is an audit mode. So specifically, if any kind of suspicious behavior originating from WMI could potentially be surfaced even more than just what's characterized in the standard attack by implementing that attack surface reduction rule and then enabling the audit mode functionality. You'll get a little bit more verbose of a warning with that.
Yeah, that's awesome. Thank you. And that reminds me, there was a great blog post about this, about attack surface reduction that came out, and I will link everyone to that here shortly. And my understanding is the only requirement to enable that in a Windows shop is just that you have Windows Defender. Right? Okay.
Yep.
That's awesome. Okay. Any idea how to tell Sysmon to record all 3 types of events rather than only the 3rd event? Yeah, I suspect, again, in this case, perhaps a component of the WMI persistence failed for some reason. So that would be the reason that I would expect that you'd only see 1 out of those 3 Sysmon related events, event ID 19, 20, and 21. I use WMI within PowerShell quite often. Can you restrict and protect WMI without restricting sysadmins or applications? Theoretically, you could. Again, everything is, there are security descriptors that can be tightened beyond the defaults. And that would be per WMI namespace. So we're not going to get into the details of how to do that. It's actually kind of tricky, especially if you want to automate that. There is a UI to do that, but just know that it's possible, and I just recommend you Google that. Just Google like WMI security descriptor configuration, that sort of thing to get you started there. Can you speak to any network controls that could be applied to prevent much of this without breaking common enterprise functionality? I couldn't speak to that with any level of authority. What I can speak to is the network components that are in play when we're talking about remote WMI operations. So again, the default protocol that WMI uses is RPC DCOM. So any of the ports protocols associated with that, which I know can tend to be not particularly firewall friendly, because my understanding is there's like ephemeral ports at play related to that. And then there's also WinRM/WSMan, which fortunately is a lot more firewall friendly, only uses a single port, and has its own security descriptor associated with that. So the security descriptor associated with establishing a remote WinRM /WSMan connection is independent from the WMI security descriptors that are applied at the namespace layer. So you'd have to have the appropriate permissions to connect in remotely first before the WMI permissions even come into play. All right. How would you detect custom objects in WMI? So this was, I believe it was Christopher Glyer who was discussing this yesterday. This was first seen, APT29 was using this as sort of like a command and control mechanism where they would create a custom WMI class, store a payload in one of the properties of their custom class, execute the payload, take the results, and store the results into another property of that same class. And because it was a WMI class and everything can be done remotely, they were using WMI as like a pure command and control channel, which was pretty impressive at the time, something we were not expecting. So how might you go about detecting that sort of thing? Unfortunately, there's not a real simple answer here. There is no built-in logging that would surface those kinds of events, like a new WMI class being created and inserted into the WMI repository. I did give a talk at Blue Hat in 2016 where I talked about WMI attacks and defenses. And so I walked through a bunch of scenarios where for every WMI-based attack, I had a WMI-based detection. And so considering how creative you can get with WMI queries, what I proposed was this query here. So this would say, anytime a new WMI class is created, do something. So in this case, the action that I had associated with it was just to execute PowerShell. And this all executed in the context of just the running PowerShell process. If you wanted to persist this, what I would recommend there would be, there's a WMI event consumer that will log to the event log. So in response to this being created, you can have an event log entry be created in response to that. Now, your mileage may vary there. I'm not sure how well you might be able to get that to scale in your environment, but I would definitely encourage anyone to play around with that. And I'll be supplying this link here in a few minutes. So what other questions do we have? What are your thoughts on the current detections available for WMI-based persistence? I would say the state of WMI-based persistence detection is good. As Joe showed, in the case of Defender for Endpoint, there was an alert that was generated. And as Julie was showing, even in the case where an alert was not generated, there's still opportunities to detect this using the telemetry at your disposal. And when I covered the WMI activity event log, event ID 5861, so even without a commercial product, you get that logging for free. It's extremely resilient against evasion, and it's just built in. You don't have to configure anything. Event ID 5861 will automatically be logged upon any sort of WMI persistence being used.
We did get one question in the chat from James regarding, could there be another parent process besides WMI PRVSE? The one that was mentioned yesterday in the slides was scrcons.exe, script cons. And so that would be another process that you could use in baselining to see what's going on in your environment.
Yeah, great question and great observation there. So in the case of scrcons.exe, the command line will be scrcons.exe-embedding, and that will always be a child process of WMI PRV se.exe. And so as Christopher was saying yesterday, when you do see that child scrcons.exe process, what that would indicate would most likely be WMI persistence, where the event consumer was one of those active script event consumers. So either VB script or JScript is executing as a result of that persistence. Now, you're not going to get any context about what JScript or VB script was executing from just the command line. But with that hint that, hey, this is likely WMI persistence where active script event consumer was used, well, then you could just jump back to the WMI persistence related events to get that context. In this case, to pull the contents of the JScript or VB script code that was persisted. But I think I can say with high confidence, having investigated this like in pretty good depth a while ago, is that like in the case of generic lateral movement, so using the create method of the Win32 process class and WMI persistence via permanent event subscriptions, those will consistently launch as a child process of WMI PRVSE.exe. But don't trust me. Certainly try these things out yourself, and try to prove me wrong. That was just those were my observations the last time I really investigated this to any level of depth. I do see a few extra ones that have come up. So someone asked, does WMIC have any different artifacts? That's a great question. So WMIC.exe is a tool that's used legitimately by administrators and also attackers to perform WMI tradecraft. So WMIC.exe, think of it like a client executable, and where the server component, the components that actually do the WMI operations, execute in the context of the WMI service. So for example, if you do, let me try to pull up an example here. So WMIC process call create notepad.exe. All right, let's spawn notepad. What you'll find, again, here, notepad.exe is going to spawn as a child process of WMI PRV SE.exe. And the WMI service spawned it on behalf of WMIC. So WMIC being like a COM client executable, it's what communicates with the server component. Again, the server component that actually does the heavy lifting for WMI. So as far as detection artifacts are concerned, in this case, like you still definitely want to be capturing process command line, because this is extremely valuable context just based on the command line alone. But just know again that the server component that WMI PRVSE.exe in this case will be spawning notepad.exe. Cool. Question about moffcomp. So can moffcomp.exe be used to register consumers in WMI? And would Sysmon Defender WMI event logging see that? Yes, that's a great question. So moffcomp.exe is an older utility that could be used to insert and instantiate WMI, like permanent WMI class instances within the WMI repository. So that is one alternative that attackers have been known to use for performing WMI persistence, where they supply a moff file which has its own syntax associated with it. But ultimately, it achieves the same goal from what we did in PowerShell here. Right, so you can do WMI persistence in PowerShell using WMIC.exe, using moffcomp.exe. There's a whole host of additional executables and APIs that can be used to do all this stuff. At the end of the day, if we're just talking about this WMI persistence, though, it's going to have the exact same detection artifacts. event ID 5861, Sysmon 19, 20, 21. They're all going to be the same, fortunately. Okay, so last question, and then we'll wrap things up. So someone was inquiring about ETW tracing for WMI. How good is it? I will let y'all be the judge of that. In the links that I posted earlier, I gave a talk at DerbyCon called how do I detect technique X in Windows? Applied methodology to definitively answer this question. So I encourage you to check out that talk. Both the slides and the video are available. So I walked through the entire methodology behind like what ETW is, how to go about identifying interesting ETW providers and associated events, applying all of it to the WMI activity provider. So there are definitely some interesting events in there that are not going to be logged to the event log by default. And so there's an opportunity to do some custom ETW tracing. This is another case where your mileage may vary, and you may not necessarily have the tools at your disposal to do this kind of logging at scale. But as a detection engineer, like just researching these sorts of things, I think ETW tracing and investigating what events are available is a really nice skill to have, so that you might be able to, like, say, reach out to vendors and say, hey, it would be great if we could get this sort of event logged in your platform. So I think we will leave it at that. I appreciate everyone sticking around for this this deep dive and the extended Q&A session. Joe, Julie, thanks a lot for your time. And everyone else, thank you so much for your time. And again, like Julie said, please do the survey. We love your feedback, and it'll just help us improve things for the next detection series that we have. All right. So everyone, enjoy the rest of your week and have a great weekend. Take care.